Alright, so for our video tutorial here for Station 1, by the end of it you should have an understanding of how to analyze the graph and look at this and say a little bit more about the description of what you're looking at. You should understand how to identify all of the key features, especially the growth and decay rate. So let's get started. The first thing we're going to look at here will be the domain and range. The domain is all of the x values that exist for your function. And I like to always try to think about this in terms of visually boxing in my function. There's a problem here. However, looking at our graph, at the ends, you see that there are arrows. Arrows mean the graph goes on in that direction forever. Well, I see that my graph's going to go to the left forever, so I technically cannot box it in on the left side. And my graph's going to go on forever on the right too, so I cannot box that in. Which means that I'm going to have an infinite number of x values that exist all the way to the left, which will be negative infinity, and all the way to the right, which is positive infinity. Now, using the same concept for range, we're going to look at boxing this graph in from the top and the bottom. So there's the bottom, there's the top. Now there's going to be a problem at the top once again, because we see that we have an arrow. The arrow means it's going up forever, so I can't box it in my graph into the top. However, on the bottom, it looks like my graph is leveling off and reaching what we call an asymptote at -1. So I know at -1, that's going to be the smallest value, output value my graph will have, and it's going to go up to positive infinity. So in function notation, we're going to say -1 is the smallest value, all the way up to positive infinity. Now we're not including -1 because this is where the asymptote is. The graph approaches this but never actually reaches -1. For the x-intercept, looks like approximately it's like -1.5. So you write -1.5. Sometimes your graph is not going to have an x-intercept. Depends on where your asymptote lies. If it's above the x-axis and you have a typical growth or decay, you will not have an x-intercept. For the y-intercept, you can identify that one. It's at 2. Now for the next portion, growth, decay, reflective growth, or reflective decay. We need to know what those look like. In general, we have growth, and then we have decay. So growth, decay. Reflective growth is just that. It's the reflection over the x-axis of those functions. That's caused by multiplying the output values by a negative number. It still has the same properties in terms of if the values are getting larger on the growth model, they're still getting larger on the reflection model. It's just they're getting larger in the negative value. For decay, same thing. Numbers are getting smaller, 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 but on the reflective side, numbers are getting smaller and smaller, just in a negative value. Okay, they're becoming less and less and less negative and closer to the actual positive values. So if we understand those, we look at our model here and we say that this looks very close to that one. So it's exponential growth. And now we look at finding the actual growth rate. So looking at the actual growth rate from a graph's perspective, we want to identify some points that we can actually accurately tell where they are located on your graph. Now these should be one x value apart, so we call them consecutive values. So if we model visually the amount that from each point it goes up, So if I go over 1, I went up from 2 to 5, I went up 3. If I go over 1 more, I went up from 5 to 11, which is 6. Now from these increases, this is how we can tell what our growth factor is. I can say, yeah, I'm going up by 3, but in exponential functions, we're always multiplying to get to the next amount of growth. So here we're multiplying by 2, and that's going to be our growth rate, 2. Average rate of change. This is going to be a concept from first semester. And I'm going to change the interval here just to use some nice numbers. Let's say we're looking from points from 1 to, 1 is the x value, to 2. We'll make it a small interval. So 1 to 2. These are x values. I want to know what is the slope of the line connecting those 2 points. So visually you can actually draw the rise and the run. I ran 1 and I went up from 5 to 11, so that would be 6. So my rate of change would be 6 over 1, which is just a value of 6. If you want to look at it in terms of points, I know that when x is 1, my output is 5. I know when x is 2, my output is 11. So we can actually do the calculation of 11 minus 5 over 2 minus 1. So we get 6 over 1, which is still 6. Either way, you can do it visually, or you can do it using the coordinates. Alright, there's your first tutorial on Station 1. Try to complete Station 1 now on your own. And keep in mind there's an answer key posted on my website already, so you can check your progress.